Live now, boom. So yes, students, we were here in the previous class on the ray optics first slide, but where we ended at the last class, anyone? Okay, one student at least have texted me. I think this is like really sincere person. Yeah. So JNV Ernakulam says laws of reflection. Arshita says, sir, we have completed up to plane mirror. Good. Very good, Arshita and JNV students. Cool. Now let me end this thing, and this thing also. Fine. Okay. So let us proceed. Okay, see, this is all the previous class parts we have seen. We have revised in the previous class again ray optics, some important terms, and plane mirror light interaction. By the way, okay, so how you overall? I mean, how you all students are? Everything is fine? Are you able to understand all the things or not? Text here. Are you able to understand all the things or not? Students, are you able to understand all the things or not? Yes or no? Yes. So, students from JNV Panchavati says yes. Fine. Okay, some few more students are there here in the class. They're also replying, so that's good. So if you will not respond, there's no use of teaching here. Okay. See how it looks if the teachers are like students are in the class and teacher is also. I mean, teacher is in the class and students are not responding. So it's like it's in the offline. I can like compare this thing as like what. If I compare this thing in offline, it looks like what? Let me tell you. Let me demonstrate this. So it's like this. You are taking some kind of offline class and like students are not present in the class. So you are just writing on the board and there is nobody in the class. So will it look good? Sure, of course, it doesn't look good, huh? So same, treat online class. Give this online class the same equal importance as you give to the offline class. Okay. That if the teacher is present, you have to be disciplined, whether you are sitting in your homes. So this is the way. Otherwise, online classes, it's like this entertainment. You are keeping the phone here on the side and like you are eating some chips, some snacks and watching some like maybe some TV or like some playing some games. Got it? So if you really want to gain the knowledge, treat online class as purely offline class. The teacher is in class, he or she, the teacher is writing on the board and all these things. Got it? I'm ending this. I've stopped the video, but let us continue with the class. So in the previous class, we have seen what is ray optics. We have seen some important terms. We have seen plane mirror and light interactions. Okay. And what are the other things? What are the other things which you have seen? See, who is this? Please mute yourself. Now, don't create irritation in the class. These spherical mirrors. So we are going to study now spherical mirrors, some important terms and numericals based on this. Okay. So can anyone of you text me like the students who have texted earlier? Who have texted earlier? Like, what are the students? Anybody from JNV Panchavati or from JNV Ernakulam? Anyone of you can text? Like, have we completed this thing? Spherical mirrors and some important terms related to spherical mirror and numericals. I mean, have you completed concave? Please mute yourself. I am telling, otherwise I will remove you from this class. Okay. I will remove you from this class. Who is this? Admin. I'm removing. Either you keep yourself mute or I will remove it. Fine. So these are the things. Okay, so let us start the class. Okay. So in the previous class, we started with the ray optics. We started with this. So 1,000 times we have seen this thing. Okay. That man-made and natural things, all these things. And we have seen what? I will show you the little bit overview. And then we have seen this thing. That is basically, these are the rays, and rays something. Principal focus. Okay, so we were at principal focus. Optics, we have seen the definitions, and we have seen the complete definition. Then we have seen the properties of light. 4 properties were there. I hope you all of you remember these 4 properties. Okay, I hope all of you remember these 4 properties. I hope all of you remember these 4 properties. Got it? I hope it's fine. Okay. One property, second property, third property, fourth property. The speed is lambda by time period. Then this, that is electromagnetic spectrum. Take. Then some important terms. Here also we have seen the definition of light ray. The light ray is something, a straight line where the arrow shows the direction of what? Light ray from the source to the receiver. Okay? It is what? A line where the arrow shows direction of light from the source to the receiver. Then what? Beam. And beam is known as what? It's a collection of rays. Okay? Then reflection. What is this reflection is? What is reflection? We have seen the reflection process also. That there is an incident ray, there is a reflected ray. It is because the light ray is incident at this point of incidence on a plane mirror, and it follows the laws of reflection, which is in the next slide. Yeah, these were some funny images we have seen already. Plane mirror we have studied. Then these were the laws of reflection, which was of importance for us. Okay. What is laws of reflection here? It says like this: I equals to R. Okay. An incident ray and reflected ray and this more normal all lie in the same plane of incidence. Got it? Fine. Then we studied about somewhat image formation due to plane. Then we studied somewhat about the image formation due to plane mirrors. We concluded here that if you are having the plane mirror, the concept of drawing the images is like this. That is the object distance D, okay, is equals to the image distance. Okay, so the object distance is equals to the image distance. Okay, then we have seen a relation between when the object is moving, or say a plane mirror is polished like this, suppose is moving with some speed with respect to ground, and object is also moving with respect to ground with some speed. Of course, the image will be moving. Then we have used this funda for derivation. Got it? And we got this formula. Let me write the formula. So after using this, we'll get the formula. Velocity of object with respect to ground is equals to velocity of image with respect to ground upon 2 velocity of mirror with respect to ground. Okay, this was the formula. Do you agree, students? Yes or no? Reply. Please text in the chat box. Okay, so when some of the students are saying yes, that's cool. I'm genuine Pancham. Okay, good, fine. So these all students are saying yes. I mean, they are clear with these concepts. We have also solved a numerical based on this, through which we got -7 centimeter per second answer. I hope you remember. I hope you remember. Okay. Next word. Next is about spherical mirror. We have studied. Okay, we studied that there are two. I've already annotated this thing. Okay, we have studied there are two kind of mirrors. Okay, let me show you this thing on a board. Okay, I'm showing you on the whiteboard. Will it work? Okay, some students want more. I mean more knowledge about this, so I'll be launching here whiteboard. Just hold. Dun, dun, dun. So I hope the whiteboard is properly available on your screens. Good, you know. I hope it's properly available. Complete white. So it's like a class whiteboard. Hope you will enjoy studying on this. So see, I'll be revising complete now spherical mirrors again. Fine, I'll give you a question also. First of all, I want to ask from you, till now, I mean till today, are you having any doubts from whatever the things which you studied in ray optics? Are you students facing any doubt from whatever the things which you have studied in ray optics? Any one of you? Any one of you students? Are you facing any doubts from whatever the things which you are studying in ray optics? Any one of you? Any doubts? So please text in the chat box. If no doubts, I will proceed. Please text. If you are facing any doubt, please text in the chat box. If no doubts, I will proceed. I'm waiting for your doubts. Okay, let me see if Zoom students are not having any doubt. Let me see what I mean. If the YouTube students may be feeling any doubt, maybe facing any doubt, huh? Because everyone is important. All the students are very much important. So, what about YouTube students? Yes. So, YouTube students, anyone? So, there are some like people who are okay. So, got it. So, yes. So, some of the students have texted. Yeah, these students are having no doubt. Cool. No issues. Harshita and all these students. Okay. So, now what we'll do is that we'll proceed now. Well, so let us proceed. See, students, so now focus on your screens properly. Okay. Be very much focused. So, write the note. I mean, on your notebooks, write like this. See, from here, actually, the original, this is what where from where the original ray optics ray optics. See, this is like a class whiteboard. Okay, so you will feel like an offline class. That's why I put here this whiteboard. Okay, so now we'll study. This is the point. I mean, this is from where the ray optics starts, basically. Okay, geometrical optics. So write the heading: black pen, spherical mirrors. Student, write the heading: spherical mirrors. I hope in your class this topic was not completed. If it is, text me. A spherical mirror is completed, text me. I mean, two type of spherical mirrors are there, concave and convex. If this topic is completed, text me. Otherwise, I'll start from here only now, today's class. That's fine. Please, anyone can text. Okay. So Shweta says, sir, it's not completed. And what about other students? I hope your answer is also the same. Naguni says, no, sir, not completed. Okay. So we'll start from here. Yes. So send a thumbs up or anything like this emoji. Okay. So we'll start from here. Good. Got it, students? Yes. So we'll start from spherical mirrors now. I have sent to everyone this emoji. Hope you like it. Oh, not everyone. I need to send to everyone. No. Everyone in meeting. Yes. So now we'll start from here only. Okay. Spherical mirrors. Cool. See, students, suppose you're having a spherical glassy material. Okay, since we are here on this whiteboard, we can take the circle shapes also. So suppose this is spherical glassy material. This is what? Spherical glassy material. All right. See, suppose if I just focus on this part of this material, only this part. Suppose I focus on only on this part of this material and I extract this part outside. Got it? What I told? This brown covered region, I mean this black periphery. If I focus on this part and if I extract this part outside, so I will get something like this. Got it? I will get something like this. Okay. Now, if I do silver polishing of the back side, if I do silver polishing of the back side, this surface, the front one, will be a reflecting surface. Then this front one will become what? Reflecting surface. And this mirror now, because it's reflecting surface and this is polished, this back is polished, as we did in plane mirrors. Okay. So now we will call this thing as what? Concave mirror. So I hope you got how we have designed this concave mirror. Got it, students? Yes or no? Yes or no? Yes or no? Anybody can reply. Okay. Now suppose if I take this part. Okay. So good. Yes, sir. Yes, sir. Yes, sir. Good. Now suppose I take this part and if I extract this out. So where I can move this? Okay, let us go to the next page. Please turn over. I'm moving here now. Okay. So if I extract this, so I will get a thing like this, isn't it? Isn't it, students? Okay, because that is leftmost side, leftmost periphery, part of the periphery of leftmost side. Okay. Now suppose if I do silver polishing of this side, that is curved side only. Got it? Now students, this, see, okay, I will use whiteboard only for the today's class because see, it's having so many colors here. Okay, you can't see, but I will show you. See how many colors it's having. It's having this color, it's having this color, it's having this, yellow, yes, this. See, colorful class. We'll make today's class like rainbow. We'll make a rainbow class. There will be rain in the class today. Okay, got it. Fine. So let me tell you this thing here. So this surface is reflecting here, by the way. And this is silver polished. Okay. And this mirror now behaves at convex mirror. This mirror now behaves as convex mirror. Okay. So from this we get two things. That is, we are having now two mirrors. So what was your topic? Topic was this spherical mirror. Spherical mirror. What was the topic? It was spherical mirror. Okay. And it is divided into two things. That is concave. We understood now what is concave and convex. And convex. Concave is something like this. Convex is something like this. These are two mirrors. Got it, students? Yes or no? Okay, now let us proceed next. So now write the new heading, that is some important terms. Some important terms. See, I'm also making the notes with you, know, so you must also make some important terms related to spherical mirrors. Some important terms related to spherical mirrors. Got it? Write this heading. Okay, I hope you've written. Okay, suppose students first write this subheading pole or vertex. Pole or vertex. Suppose students I take a concave mirror. It's a concave mirror. Some say concave, some say concave. Suppose let us take a concave mirror. This is what? Concave mirror. It's a type of spherical mirror. Okay. So students, what is pole on this mirror? Where is the pole? If I draw a concave mirror, pole is this, you can say a middle kind of point here. This point, students, is known as pole or vertex. Pole or vertex here. ठीक है? Got it, students? Good. Now, if we take, okay, if you understood this, this will also be valid for your kind information. This will be also valid if we take convex mirror. See, this is what? Convex mirror. Okay. And what will be the pole defined here? Again, the pole will be defined center point only. So this will be the pole or vertex. See this, now you will feel very much interested in ray optics because this is actually from where the optics start. I mean, you'll find questions in IIT, NEET, Delhi University, Banaras Hindu University. Okay, even in higher exams like IIT JAM. Okay, or like somewhere like in GRE and all these things. You'll find these level questions. Okay. So if you'll study now with very much focus, it will be very, very beneficial for you in the future. Yeah. So for convex mirror also, students, for convex mirror also, the pole is same. Got it? Yes or no? I hope it's clear. Now, students, write the new heading, subheading. So after pole, what's the next thing? After pole, we'll see center of curvature. Write the heading center of curvature. Okay, so first let us take, see, since I am also making the notes with you, you must also say I am writing on the board. No, so it's complete. I want you people to like feel like this. It's like an offline class, and the teacher is writing on the board. Okay, so this is center of curvature. So suppose let us first take concave mirror. Then we'll see the center of curvature of convex also. So suppose I draw here a concave mirror. And we know already which is the pole point. Pole point is this. This is pole or vertex. Okay. So where the center of curvature lies, by the way. See, center of curvature in this will lie. Yes, this is a straight line. So center of curvature will lie where? It will lie at a point here. Okay, which is at r distance. This is what distance? R. Where r is known as radius of curvature. Where r is known as what? Radius of curvature. Okay, fine. But if some, okay, let us define for this convex mirror also. So center of curvature and radius of curvature is clear for concave. Now what about convex? If I talk about convex, convex looks how? It looks like this. This is known as convex mirror. This pole is known as, this is known as what? Pole or vertex. Okay. So now if I want to show the center of curvature, it will lie where? Can anyone reply me? Suppose I draw a straight line passing through this pole. Okay, let me remove this first. Suppose I draw a straight line passing through this pole like this. Okay. Yes. So one of the student, intelligent one like Veena says behind the mirror. Very good. So we'll say here the center of curvature point will lie behind the mirror, maybe here. So I can say like this now, students, the center of curvature point will lie here. Okay. And it is at a distance r. Okay. But if someone asks from you, just physically define me. I mean, what's the physical significance? What is physical significance? How will the physical significance? Physical significance of you. What you will answer? What is the center of curvature? So you will say like this, ki sir or ma'am, center of curvature is the center of that spherical glassy material. Spherical glassy material whose either concave or convex mirror are parts. Okay, so that is the thing, no? I hope you understood the definition. So now let us move further. So we got all the points. Now I'll be fast somewhat. Okay. So we understood pole, which is pole or vertex. See, in your class, I'm teaching very slow. In others class, I was very fast in these points. Then we studied about center of curvature. COC, the center of curvature. Also, we studied about radius of curvature. Now focus. What is focus? Okay, I'm showing you fast. Suppose you are having this kind of thing, that is a concave mirror. And see, if you draw a straight line, this line is known as principal axis. Remember one more thing, okay? Include this also in heading. I mean, one of the sub points, some important terms. Principal axis. A straight line passing through the mirror from between is known as principal axis. This is known as pole or vertex. This is principal axis, okay? And this point will be center of curvature. Got it? And this distance from the pole and the center of curvature is radius of curvature. But our requirement is what? We want to understand what is focus. Focus is, students, at a distance r/2 from pole, or you can say from center of curvature also r/2. Because if it is at r by distance from pole, of course, center of curvature is at r. Remaining will be r minus r/2, which is again r/2. Okay? Yes, students? I hope it's clear. So focus is at r/2. Good. Same is for convex also. Okay, I think I need to draw it for you students. So this is a mirror. It's a convex mirror. Okay, I'm telling you, one of the students says what is focus. Okay, so I'm giving you one more simple definition of focus. Just see here. Suppose you're having this concave mirror like this. And straight line passing by a concave mirror is like this, suppose, from the center. Okay. This is center of curvature. This is focus. This is pole or vortex. So there is one rule of image formation. Via that also we can understand what is this focus point. So via that also we can understand what is this focus point. Okay, let me show you. Suppose a line is parallel to the principal axis, is incident on the concave mirror or spherical mirror, whatever you can say. Suppose a line parallel to the principal axis gets incident on this concave mirror. Then what happens is that, always remember this rule. It's a rule, it's a law. It's a rule, it's a law. Don't break the rules. Now you will say, sir, rules are made to break. No, it's not like this here. If you break it, it will break you. I mean, you will not get the marks. Yes. So what happens basically, when the ray is parallel to the principal axis, it always passes through a point which is known as focus. Okay. So this is the focus point. But what is it? It is actually in between the midpoint of the pole and the center of curvature. If it's midpoint, center of, see, you can see like this, no? Center of curvature and pole ke beech mein distance kitna hai? R. And focus is here, which is at a distance R by 2 from pole. Okay. Midpoint, it's at the center. So this is also R by 2. So this point is known as focus. Got it? Now let us see the next thing, that is, see that same also you can apply for the convex. Now I will not show again and again for the convex. Now what is focal plane? Now let us see, students, what is focal plane. Suppose this is the principal axis. Okay. And focal plane's focus is this at a distance R by 2 from the pole. Of course, at more distance R by 2, one more point will be there, which is center of curvature. So what is focal plane? What is focal plane? See, so it's a plane basically which is perpendicular to principal axis and it passes through the focus. You can say like this. Suppose there are many rays which are incident parallel to the principal axis. So all these rays, after reflection from this spherical mirror, say concave or convex, will pass through a plane or appear to pass through a plane in case of convex from a plane which is known as focal plane. Okay. Focal plane. Fine, students. I hope it's clear. I hope it's clear. Yes. So now all the points are cleared. Yes, we have completed pole, vertex, center of curvature, radius of curvature, focus, focal plane, all these things. Okay, and one more thing appearing. One more thing is pending, like aperture. What is this aperture point? Suppose you're having a concave mirror like this, or say convex mirror like this. If you join these 2 points, this and this, okay, this point is aperture. If you join these 2 points, this is what? Aperture. Okay, it's not a diameter, but if you join these 2 points, you will get the aperture kind of thing. No, don't take it as a diameter. It's not a diameter. Diameter, though, it's 2r. It's not 2r basically. Okay, so if I extend this, I'll get the sphere from here. This point I will say as a diameter. That is 2r kind of thing. If you see the top surface, but this is not 2r. It's less than 2r. It's less than 2r. Okay. So this is known as aperture, like a chord. Okay. I hope you understood. Fine. Now students, write a formula. Okay. So now I can project from the screens. Yes, fine. So see here carefully, pole, vertex, all these things I've already written here and noted. Yes. So some rules for image formation. Write the heading fast. I hope you have written like this. Okay. I'll be very fast in this. So rules for image formation says like this. I've already told you, if a ray is parallel to the principal axis, it reflects, is incident on the spherical mirror, say concave. It passes after reflection from the focus point. This is focus. Okay. Again, if a ray is parallel to the principal axis, if it is incident on this mirror, it appears to pass from this point, which is known as focus here. ठीक है, समझ में आ गया? Fine. Now, what's the second rule of formation? I mean, these are things which you must remember. Yeah, I have already noted this. So it's a reversibility. Initially, I've told you, suppose you are given a concave mirror, and this is a pole. Focus, curvature. If a light ray passes parallel like this, so it will pass from the focus. But what happens if I like reverse it? That is, now if the light ray is passing from the focus, if the light ray is passing from the focus, it will be parallel to this principal axis. It's opposite. That's why it's known as the principle of reversibility of light. Okay. If light ray passes from the focus, it will be parallel to principal axis. And in convex mirror, suppose if the light ray appears to pass from the focus, it will again become parallel to the principal axis. Okay? I hope both laws are cleared. Now, this also is important. Suppose in case of concave mirror, if you incident a light towards the curvature, center of curvature. In case of concave mirror, if you incident the light on the center of curvature, it will retrace its path. Okay, and in this case of convex mirror, if the light ray passes like this, I mean, it appears to pass from the curvature, again, it will appear to retrace its path. Okay, and see, you now you can say this thing, center of curvature is a point, and this angle from this short mirror kind of thing, if you take a part of the spherical mirror, it is perpendicular. So here, angle of incidence equals to what? 0 degree. Angle of reflection again will be 0 due to laws of reflection. These things you must know. See, the sentence, I mean, physical significance is like this. You can explain through this I equals to R thing, but you must understand this, that if a ray passes from the curvature, it will retrace its path. It's a law. Okay? It's a rule. Always remember throughout your life. Okay? It's important. You'll get, I mean, these are the things on behalf of which we'll be solving the questions. Now this thing, rules for image formation, what is it? Suppose you are, see here actually it's given convex, no issues. Suppose you are given, yes, suppose you are given convex mirror or concave, whatever. If the ray is strikes at angle theta with the principal axis at this point of incidence, pole, again it will go making an angle theta only. Got it? Due to laws of reflection. Same if I take for concave mirror, again it will do the same. Same thing will happen. ठीक है? Fine. Now students, write the relation between UV and R. I'll solve this. I mean, I will not derive it, but one question we have to solve at least. Suppose this is, students, a mirror, which is a concave mirror. This is principal axis. Focus, curvature. Suppose an object is lying at a distance U from the pole. Okay, an image is somewhat say here. I don't know where it is. So the formula is defined, which gives you the relation between image distance, O is object distance, okay, and focus. This formula is this: 1 by V plus 1 by U equals to 1 by F. Sign and conventions are what? That suppose if you start from the pole, so don't make noise in the class. Suppose you start pole. If you move toward the object, if you're moving against the rays of the object, you will take direction as negative. If you start from the pole, you move in the direction of the light rays, it is positive. Okay. Don't worry. Now I will solve one question and then you will get it. Okay. So see students in front of you on your screens, there is a question. We are still having 2-3 minutes. I will solve the numerical here. See, unless and until we solve an application, this will not work. Anna, applications are important because why are studying the theory and concepts for solving the applications only, no? Got it? Yes. So see here carefully now, students. Look here on the screen. See. See here it's given a pole origin 0, 0. It means, of course, इसमें तो सोचने की भी जरूरत नहीं है. This direction is negative. This is positive. Radius of curvature is 20 centimeter. Object is at a distance 30 centimeter. ठीक है? Now if apply all the things here. So we are having the mirror formula as 1 by V plus 1 by U 1 by F. ठीक है? So how to solve? They're asking from you find the position and the type of image form. So it's very easy. How to solve? See if you start from pole. Yeah, one of the students, Shweta, have already given the answer. Very good. Excellent. See if you start from pole, if you go towards the object, it's negative direction. But the object distance is 30. So, but the sign in convention, if we need to take, it will be minus 30. You will take as minus 30. Because we have to measure. See, remember the sign in convention? Measure. Always measure in this numeric, these kind of numericals, always measure all the distances from pole. Okay. If you start from here, go towards this, it is negative. U is minus 30. Okay. V actually they're asking from us to find out, and we are having radius of curvature. See if you start from pole, if you go towards the radius of curvature, it is what? Again, it is negative direction. So it is minus 20. Focus is defined as R by 2. So if you will solve it, you will get minus 20 by 2. That is minus 10 centimeters. Okay. Now what are the things which we are having? We are having focus. Just put here. We are having U. You have to put this here in this equation. We'll get V here. Okay. So let us solve this thing. Yes. So I'll be solving. Yes, students, I'll be solving. Don't worry. 1 by V plus 1 by U equals to 1 by F. U is minus 30. How much? Anyone? You are saying why F minus 10? Okay, let me tell you. See this. F is defined as basically R by 2. We are here given as R as 20 centimeter. But R is negative and also F is negative. Because see where the focus and all these points will lie. Where the focus and all these points will lie. Focus will lie at, suppose center of curvature is 30. Focus is at 15. Sorry. No. The radius of curvature is at 20. That is center of curvature will lie somewhat here. So focus will lie 20 ka half. That is 10. And it's negative direction. That's why I took minus 10. Got it? Shweta, you got the thing. Focus is minus 10. Okay? Because it's R by 2 and R and F are in the same direction of the opposite side. That is negative direction. I hope it's clear to all the students. Shweta and like all. Okay, very good. So now F is minus 10. If you'll solve this question, you will get common it. I took different colors. No issues. It looks somewhat different, weird kind of. So it's like minus 2 by 30, 15, 1 by V. So from here you get V equals to minus 15 centimeter. This is your answer, students. Yeah, Nagvani has already given the answer. Very good. Right answer. So we'll say like this. That was another question. So the image in this picture, if object is at 30 centimeter negative, image, see we have to start from the pole again. हमें कहाँ जाना है? Image कहाँ है? Image is at, answer is this, V minus 15. So we have to go 15 units negative. That is, this direction is positive, this direction is negative. So 15 units negative means yahan pe sorry. So image will be students here. Okay. So if the object is at 30 centimeter from this mirror or pole, image will be 15 centimeter from the pole, like this. This is object, this is image. Is this solution clear to all of the students or no? Text me fast so we can end the class now. Please text students here. Is this solution clear to all of you or not? Very good. Arshita, yes, cool. Okay, Nagvini, yes. Okay, what about other students? Okay, Janvi, okay, she's okay, good. See, students, before ending the class, please note this question as a homework. Tomorrow I will start the class with this question as a revision question. Okay. Before ending, take this question. Note down this question as a homework. Take this question as a homework. Whenever the next class will be there, we'll start with this question as a recall question. As a recall question. इसमें क्या करना है? Same question as the previous one. This is concavo mirror, not concavo, it's concave mirror. Radius of curvature is 20. This side is negative. This side is positive. Sir, please use different colors. Negative, positive, concave. Object is at 5 centimeter. U equals to -5. You have to find the V. Very simple. Focus you will take again negative because it's curved like this. So center will be here. Focus also will be here. So it's -10. Focus is -10. R by 2. Solve it. You'll get the answer. Got it? Okay, students. Bye bye, everyone. Take care. Very good. Pavitra, bye. And all the other students, bye. Nagvani, good answer. Okay. So I'll give you the hint. Virtual or real image you have to find. The image will be virtual or real. You have to see all that also. Okay. Bye bye, everyone. Okay. Bye. All the students. So now I'm ending the class. We'll meet in the next class. Okay. Bye bye, everyone. Take care. Study well. Okay. Yes. Bye bye. So I'm ending the